Now it's
no change. So just that one symbol. Yeah, I know. So if you might not know, so you just add symbol on part C. You know what I'm talking about? It just take about 2 more minutes. Right, I need you to classify them under have I covered page 12 already? No, sorry. Okay. I thought we were finishing. Okay, my fault. Then I'll just go through page 12, right? Okay, some answers. Okay, this is what you should be copying. Okay, you have copied your concept map, right? I've went through the concept map before. Atoms, molecules. So we just go through this little things. Okay, page 12. Let's do this one first. Okay, just run through some of the terms. If you have a concept map, which I went through last week. Is it last week? Yeah. We said that atoms can form molecules. If atoms and atoms chemically combine together, they will form molecules. Right, and there are two types of molecules. Right? If you recall, there are molecules of elements, and there is molecules of compounds. Non-matter plus non-matter chemically combined. This one is you have copied already. So I'm just telling you what we have molecules. And I mentioned in covalent molecules, there are two types. There are either molecules, covalent molecules of elements, or covalent molecules of compounds. Right, where do we classify as such? We have molecules of elements. It is when all the atoms are in same element. If the atoms are all the same, okay, and it will be called as molecules of elements. That means one type of atom. Whenever there's only one type of atom, that whole substance will always be called elements. And usually, all these atoms I'm talking about is non-matter and non-matter atoms that's interacting with one another. So far, can you follow? Can I move on? I'll move on. Okay, these are a few examples of molecules of elements. You do not need to take note of this picture, but do take note of this view. Let's say when we always mention oxygen gas you breathe in, you should not think of oxygen gas as an atom. You are not breathing in atoms. Instead, what you are breathing in is oxygen molecules. Right? That means you are breathing in 2 oxygen atoms at once, every time. Okay, 2 oxygen atoms breathe in through your nose every time. Okay, and these oxygen atoms are chemically combined together. So we call it a molecule of element. Okay, oxygen. Again, the nitrogen gas, where we always mention, oh, there's nitrogen gas in the air. We shouldn't think of the nitrogen is just an atom floating by itself. Instead, it is two atoms floating together. So it is a molecule of nitrogen in the air, right, as a gas. Hydrogen as well, H2. So there are few elements that is always present as couple, like that. Okay? Phosphorus is a weird one. You do not need to really be concerned with this one. Just to let you know, sometimes element is not always coupled. Okay, this one is just for your knowledge. Right, for now, phosphorus. It's really for your information, not really exam thing. P4. That means these atoms, whenever you go to somewhere, say scientists, or we discover phosphorus, hey, that's a phosphorus thing. We just say thing. But when we take out under microscope, we see that there is 4 atoms chemically combined together. Alright? It will never be one atom by itself. It will be 4 together. Alright? Chemical formula wise, how we represent the 4 atoms, you write P4. Right? As I walk around, take note. So most of you have done very well. Alright, the numbers you have written at the corner. Right? Do not write side by side. So when in exams, you must take note to write at the corner instead of writing side by side like that. I'll move on to the next one. Molecules of elements. So the main 3 parts that you need to focus is the first 3, the hydrogen, oxygen, and nitrogen. Because these 2 elements, they are always present as a molecule, and they are the same atoms coming together. Same atoms chemically combined, we call it diatomic. Where di represents in chemistry, di represents 2. Like carbon dioxide, the word di, Di. Di, it refers to the word 2. Okay? It's not these are new. It is 2. So 2 atoms. So these molecules are hydrogen, oxygen, and nitrogen. They are always 2 atoms. Right? There are other elements that are always present in 2 atoms, such as the chlorine. So those people who use like the bleach or the washing powder and or anything that you use in detergent, chlorine that is present inside. There are always 2 chlorine atoms together, 2 Cl atoms joined next to each other. It's not one atom, it's always Cl and Cl. Alright, Cl being a symbol. So if I write the chemical formula, it is written as Cl2. Iodine. Have you learned food test or starch? Something have you used iodine on starch before? Yes. The iodine that you use, iodine solution to test for starch, it is not present as just one atom. Usually, iodine is present as 2 atoms chemically combined. So it's a diatomic. So your iodine is always like that present. So whenever you drink on your starch, you're drinking 2 atoms together. Right? I2. Why is it so? Because you will learn it in year 3. They are more stable like that. Okay? I will give you more knowledge later on, step by step. Okay? Just to know all this one. Bromine, it will always be Br2. Okay? That's it. So you realize that actually it's H2, N2, O2, and these 3 are actually all your group 7. All your group 7 elements. All your group 7 elements will always present in the diatomic format. Right? Let's say if you flip to your periodic table, okay? If you flip your periodic table, if I just anyhow give you see the elements with a symbol F. What is the element F called? Fluorine. So does fluorine present as like that F? No. It's under group 7, so you always need F2. Okay? You follow? So all the group 7 elements, they always be 2 atoms together, and H2, N2, and O2. So group 7 and all this. My ex-students used to try to remember by this one. Oh, how do I remember which other? Diatomic. I don't know how he actually come up with this one. He just put this. No, you remember like car brands like Honda, right? You know Honda, right? But he doesn't call it Honda. He call it Hon 7. Okay, but I don't know. He who was quite effective with the class that taught HON 7. Hydrogen, oxygen, nitrogen, and on the group 7, there will always be 2 below. Alright, that's atomic molecules. Right, I'm trying to help you to find ways to memorize. Then HON 7. Whenever I mention HON 7, that means they are present in molecules. Okay, I'll move on to molecules of compounds. Molecules of compounds wise, what you need to take note if you go back to your concept lab, as long as there are different elements or different elements chemically combined, will be known as compounds, covalent compounds. Okay, different element means different type of atoms. So for example, H2O. H2O, you have the hydrogen element, you have the oxygen element, different elements. So this is known as a compound. Okay, but one thing you should take note of, regardless of this compound, whether it's in solid state, liquid state, or gaseous state, right, the number of hydrogen atoms or the number of oxygen atoms is always the same. Like the number here, 2. 2 represents the number of hydrogen atoms, H2O. Right, there are 2 hydrogen atoms chemically combined to 1 oxygen atom. Whether it's in solid state, liquid state, or gaseous state, it will always be these numbers. Right? You don't need to see it changing. Right now, move on. Question. Okay. Right, so that's all. Okay, next one is some examples. H2O, CO2, NH3, HCl. How you can see that these are molecules of covalent compounds. Actually, these are covalent compounds. You will see that, let's say, for example, CO2. C is a non-metal element. O is a non-metal element. So if you refer to a concept map which you have drawn it yourself, okay, you should see that non-metal plus non-metal will form a covalent molecules. The drawing wise, if you are unsure, do you have to draw in such a shape? For now, don't worry. If you are trying to draw the H side by side of the O, then it's perfectly fine. Alright? Why this shape? We're going to touch it at A level, not now. Don't worry. So long, your H is nothing the O. Alright? Not H nothing the H. Like this NH3, not H nothing the H, but H nothing the N. Right? Shape, don't worry too much first. What is really important for you right now is to classify whether it's a covalent molecules of elements or covalent molecules of compounds. More important. This is more important right now. This is HCl. H is a non-metal element, Cl is a non-metal element. So it's a covalent molecules of compounds. Okay, whenever you're ready, you can take some time to complete. Now we can complete page 13 and 14. I give you up to 9:15, right? 9:15, and I'll go around asking for your question. Let me know. Right, 9:15 to page 13 and 14. You may go ahead and discuss with your friends, right? Just because you'll see it. there is more than one atom. As long as all the atoms are all the same, this one is the molecule of molecule not molecule. It's blue one. Okay, for some people who are working, alright, I did some changes to the concept map. I think it was nearer to what I given you. What is a molecule? Whenever you see the word molecules, it means that there is more than one atoms. More than one atoms, then we know that that thing is a molecule. But if all the atoms are all the same type, I use the word type, probably it's easier for you to understand. If all the same type of atoms, then we call it molecule of elements. Okay, molecule of element. If the atoms are all, it's a bit different, there is one different type, then we call it molecule of compound. So it is, there are two types of molecules. Right? At the end of the day, I need you to know that there are two types of molecules. Either we call it molecules of elements or molecules of compounds. Right? So there are two types of molecules. Yes. So ready or should I go through? Right. Yeah, I'm just going through the answers. Okay, let's just follow the concept map if you have. This one, A, all of the same type, we have three happy faces. So, could we just probably get Stephanie? A, would you like to get, can I get a response? How would you classify A as? Molecules of elements. Erika B. Agree? Yeah, thank you. Molecules of elements. Okay, next. Can I get Jubina? Part B. How would you classify this? Molecules of compound. Thank you. C. Okay, molecules molecules of compounds is not perfect. Good. Last one. Can I get Deborah? Atom. Good. Right? This is just by itself. So it's an atom. So check this one. Part E. Right? Part E. They tell you that B is actually representing CO2. Could you tell me triangle is representing C or the square is representing C? What is above? Square or triangle is representing the element C. Carbon. Triangle. Thank you. So if this is C and this is 2, O2 like that. And then C, part C represents NH3, so this is NH3 like that. So how would you draw your NO2? To draw your NO2, I'll just review the answer. So it will just be 1 part and 2 square. NO2 like that. Okay. Take note, in exams, this is really for really minimal understanding. In exams, we will never come out heart shape, square shape, triangle shape for you. Right? We will never ever come out like that. What we will come out, NO2 is it. Right? In exams, we would like you to actually draw circles for all of them. NO2. This is the more proper one. Why we purposely for now the square shape element? This is another type of element. Okay, for your learning. Now we are drawing all three. Okay, so I'll end page 16 of the notes I will skip is atrocious drawing. So I will go through. Okay, we'll take a break. I don't know, I'll show you a video. Either you want to watch or you want to zonk out. It's either one. Right, I'll show you a video on periodic table. that's the end of the whole thing. Can I give you a break up to 9:20? I'll give you a break up to 9:25. Then I'll begin. Right? You want a break? Or you want a break? I continue. Want a break? Break? Okay, I'll give you 9:20 up to 9:25. Then we begin on the next class. Okay? Oh my God. Go back to your seats. Now, the chemistry quiz, I will try to come up with an ungraded one next Monday, as I said. Then I can give you feedback by Wednesday, then Thursday is on quiz. I don't know how many percent is this one, but you take notes. It's only on notes 1, meaning of atoms, ions, and ionic compounds. Right? Know how to join ionic compound, like legend, the brackets, and everything you must know. Alright? If there's any questions from now to Wednesday, you have a lot of time to ask. Huh? And I'll check through the worksheets. So, we're going on to the next notes. This is not in the quiz, but we're going on first. Periodic table. If you haven't know what is the method and non-metallic side, you can start to draw the staircase if you want to summarize. This is the staircase I'm drawing, right? And there are different colors for you. What does it mean? The white color one represents the non-metal. These are the non-metal. Noble gas is considered non-metal, but because they're so special among the non-metal, this particular zero, we call it the noble gas. Okay, noble gas, they are the unreactive and they are inert. That means they don't interact with another atoms. They always remain as an atom. They don't interact with other atoms as well. Right? Okay, then we have, we can ignore this one. These are the rare earth metals we won't be touching. Why rare? Because it's, as the name suggests, we can't have much data with that. So we can't place them correctly in the periodic table. Then the other side are all the metals. The blue color, orange color, light blue, and the yellow. But among all the metals, there are different classification as well. This block is called a transition metal. I will tell you why is it called a transition metal later. Then this is called group 1 metals, group 2 metals. This is called group 3 metals. Blue color one, we might call it poor metals. Why call poor metals? We will not be studying now because they don't react as well as the group 1 metal. So you call it poor metal. Okay, there are some classification of different types of metal. Alkali metal, alkali metal. Are we tested? Not tested. But just to let you know, there are different classifications among the metals itself as well. Okay, so do not worry too much. Okay, can I just move on, or do you want to still color? Give it a minute to color. I know you all like color. Okay, just color whatever you want. But yeah. Okay, signal of group 1, group 2. These are the two main things. And group 0, the noble gas. Yeah, take note group 1, group 2, and group 0. That's it. Okay, I'll go on. You're complete. Yeah, Cheryl. That is different. So just take note of when approximately when the fission period. The elements are which one? You can do all those things. You need to know. So one really good to know. That's why I say just group 1, group 2, and group 0 is the main concern for now. Okay? The one that's given to you is a standard O-level periodic table. This one is from the Google image, so it's not the real one. This from the Google image, so you won't be seeing this on the O-level. What you'll be seeing in the O-level is what you have on your notes. Okay? Okay, never mind, I'll go through. Next one, copy. So you copy first, then I'll go through. First 4 sentences first. Just first 4 sentences. Okay, so we are revisiting some of the terms that we have done, like proton number. Another name for proton number is also called atomic number. Okay, go back to your notes 1 to see why proton number is also known as atomic number. Okay, so let's take note. The vertical columns, right? Vertical columns means straight down. You have the group. Right, so you have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 0. What does the group number tell you? It tells you the number of valence electrons. In other words, for valence, if you're not very comfortable with the word valence, you can use the word outermost. It is perfectly fine. So these two words are interchangeable. For valence or outermost, it has the same meaning. Elements in the same group, it has the same number of valence electrons. So for example, if you look at the periodic table, you have your fluorine, chlorine, iodine, bromine, all these things, they are group 7. And all of them will have 7 valence electrons. Okay, you don't have to write out the electronic configuration to tell how many. But for the group number, you can tell how many valence electrons. The next 2 sentences, right, tells you how we read the periodic table horizontally. Horizontally, we call it period. And what does the period tell you? It corresponds to the number of electron shells. So period number 1, let's say your hydrogen and helium only, that is considered period number 1. Lithium and beryllium, that is considered period number 2 if you refer to a periodic table. Okay, period number 2. So do take note period. Again, I need to emphasize your group number is written as a Roman letters. Okay, Roman letters, like what you have seen in periodic table. Period, you can write in the Arabic number 1, 2, 3 like that. Right? Dividing line is fine. Now, metals. Generally, the metal side of the periodic table, like group 1, group 2, group 3, these are the metallic elements. Because they have 1, 2, they have 1, 2, 3, so to say they have only 1 valence electron, 2 valence electron, or 3 is considered few. They will usually, that's why we use the word tend to. They will tend to lose electron. Once they lose electron, they will become positively charged ion. Could you think of another word to replace positively charged ion? Just another word to replace positively charged ion. Okay? Positively charged ion. Could they get another name to name called positively charged ion? Okay, thank you. Alright, so another name is called cation or positively charged ion. And on the other hand, really on the other hand, the other side, the non-metal. The non-metal, they have more valence electrons. We are more concerned with the non-metals of group 5, group 6, group 7. So group 5 have 5 valence electrons, group 6 has 6 valence electrons, group 7 has 7 valence electrons. So these groups, they tend to gain electrons. Once they gain electron, they will have more electrons than protons. So you become negatively charged ions. Amanda, could you suggest another name for negatively charged ions? Okay, thank you. Alright, another name for negatively charged ion is also known as anion. Then the middle part, I mentioned the transition metal. Why is it called transition metal? There's special property. How special are they? Okay, I'll show you how this looks like. Okay, just for your information right now, what I mean by now sodium atom is group 1. Let's do a scribble here first. Don't have to copy this one. Why do we mean by special? Group 1 is sodium atom. So it loses that one electron, it will form what type of ion? It will form Na plus ion. Group 2, Mg atom will form Mg2 plus ion. I hope you see the pattern a little bit. Alright? I'll come to that again. Group 7 atom, you'll usually form chloride ion, Cl minus ion. Right? Because 7 valence electrons, you need to gain one more electron. Right? Just one more electron that becomes Cl minus ion. Now, when they form ion, like sodium atom will only form Na plus ion. Nothing. It will never form Na2 plus. Never. Mg2 plus will always be formed. It will never form Mg plus, neither will it form Mg3 plus. No such thing. But for transition metal, that's the weird one. I'm going to erase all this thing. For transition metal, for example, I give you an example like copper. Copper atom, no group, they are transition. Either form copper 2 plus ion. It can form copper plus ion. Why? Not going to explain to you right now. Right? So, how special? If you want to know, I can only generalize for you right now. Because you can write on the side, they form more than one type of ions. Because they form more than one type of ions, like copper. Okay, if you write, for example, copper atom can become Cu plus ion or Cu plus ion. Okay, so for those who are interested to know why, I can tell you after class. Okay. Right now, let's be really focused on group 1, group 2, and group 3, or 5, 6, 7 like that. For transition elements, we won't really ask you, but there is some to memorize like copper. Okay, there's some of it to memorize. But how we define transition metals? Why are they grouped there? Because you can form more than one ions. Okay, I'll move on to the next one. Okay, I'll give you time up to 9:45, right, to do this paper. We just try to finish this one by today to do metallic single ions. Now, can you change a little bit in the notes? Can you write, okay, chemical formula instead of just writing the formula? This one. A few things I need you to add on the table so as when you study, everything is consistent. No, okay. Sorry, I'll do it after class. Okay, the word chemical formula is at it. And then there's another one called ion of an element. you change this one as well. Change this one iron as element and this one as chemical formula. Right? If not, you can have the next 5 minutes read the table. Right? The next 5 minutes. Do it slowly and carefully, don't rush through. I want you to go through slowly. Yes. Yeah. Do you know what is chemical formula? No, okay, sorry. So chemical formula means like, let's say, the ions, the symbol of the ions that is formed. Let's say the first one, lithium, that's a chemical, alright, sorry. Chemical name should be this one, lithium. But the chemical formula, this is a chemical symbol for lithium atom. In lithium atom, you write is Li atom. But when it forms an ion, you write Li plus. So this is known as the chemical formula. Right? The symbol with a charge. The symbol with a charge, we call it the chemical formula. Okay, if I were to define what it is by chemical formula, it's the symbol of the elements. Okay, so for lithium, the chemical formula will just be Li. For magnesium, it's just Mg. Right, for example, like sodium, I see a lot of you written correctly Na, so on and so forth. Okay, now I'll go through. I spotted some. Instead I'll show you the answers, I'll show you how I go through. Today's lesson will be ending in this on this paper lessons. Now, chemical name. When I ask you for the name, take note in exam, when I ask you for the name, you jolly well spell out for me yourself. Unless the heading says chemical symbol. If I say chemical symbol, then you write Li, then I'll mark it correct. So you must take note when to write correct things. Name means I ask you to spell out, and not just write Li. Okay? So I know you know. Now we're going into fine-tuning your answers. Okay? How to show that people you know it's correctly. Electronic configuration. Right? If there's 3, atomic number means the number of protons, proton number. I hope you know this one. Proton number. If there's 3, that means there's 3 protons. If there's 3 protons per atom, how many electrons are there? 3 electrons. So electronic configuration is just basically 2.1. Right? Not because you are class 2.1, I run 2.1. I hope you know why 2.1. Because of 3 here. Okay? Do not draw the thing. Drawing is okay, but if I ask you to draw, I would ask you to write, I will ask you to draw the electronic structure. Right? Numbers is configuration. Next one, group. I just mentioned 2 minutes ago. Then after that, when I ask you to do, you're anyhow already. Group number, if you refer to the table, is group 1. Okay, some of you write like that. I cannot see very clearly. Later, when I see that, how I spot a mistake because some of you write group 2 like that. Can I write group with Arabic number? No. That's why I need to emphasize again and again. I'll make a cross here for you to know. Group 1, I write properly. Then I'll let people know. It's group 1. Group 2. Right? Actually, yeah. If I were to be really now in upper set, the teachers will really require a lot more precision. I'll just teach you the right thing. You just write 1 like that because I'm using it as I something. So it's better to write group 1 like that. The proper way of writing the whole thing. Okay? Are we fine? Then I'll go on to the 4th row. Chemical formula. Chemical formula means the symbol. Now we're going to the ions form. Ions form, because it's a group 1, it will lose 1 electron. Right? So initially 3 proton, 3 electron. If it loses 1 electron, it will become from 3 protons to become with 2 electrons. So if protons is positive, this one is negative. How many more positive than electron? 1 more. That's why the charge is Li plus. Charge will be either you can write 1 plus, I'm fine, or you can just write plus. Right? You can omit the number 1 in the chemistry. I need to see plus. Electronic configuration will be 2, just like that. I'll go through 12 first. 12 is of magnesium. Correct me if I'm wrong. This one will be initially is 2.8.2. Group 2, if it is 2 valence electron, it will be forming Mg2 plus. Okay, I can go through this one with you. You get 12 protons, it means 12 electrons. So if it loses the 2 electrons, it becomes 10 electrons. Okay, loses 2 electrons, 10 electrons. So how many more positive than negative? 2 more. That's why it is 2 plus. I ask you the charge. When you're writing this one, you're actually writing the charge. Don't just write not knowing what it means. This numbers and the sign represents the charge. Okay? So the charge over here will be written as 2 plus. Now, some of the things that I probably need to correct. 2 and plus falls on the same line. It is not like that. 2 plus like that. It's not written like that. Okay, it's 2 plus. 2 and plus side by side. But if you have a symbol, the 2 plus is on the top right hand corner. Okay, just take a look whether you have followed how we write things properly or not. The electronic configuration will just be 2.8. I'll go through one last one. I think. Is this aluminium? Aluminium. Okay, aluminium is the 2.8.3. So it's group 3 Al3 plus 3 plus 2.8. Okay, I'll review the answers of all of them next lesson. Okay, so please make sure you get the group numbers correct. The ions is possible. We are going to focus on group 1, 2, and 3 from now first. Okay, step by step. Then the electronic configuration, this is for the ions, this is for the element. Now, this one, if you want, you can jot it down, extra stuff. Huh? This one is what we call the noble gas configuration. All these numbers have written is called the noble gas configuration because either they have the last number as 8 or the number 2 over here. Right? So this is the class. Thank you, ladies. Thank you, ladies.